Alrighty, this is chapter 11, multiple methods. Two or more approaches are better than one. So in this exciting chapter, we'll talk about the logic of triangulation and like what the hell that means. We'll talk about composite measures and how you can make them yourself. We'll talk about structural equation modeling. Yay! We'll talk about replications, whether that's using the same research strategy as previously or replicating research with different research strategies, because remember, replication is science. And we'll look at different comparisons of approaches to social research. Alrighty. So the logic of triangulation. So first off, what the hell is that? It's just the use of multiple methods to address the same research question. So throughout different lectures, we've looked at many different methodologies, and each of those we've talked about the strengths and the weaknesses of those different methods. So the point of triangulation is to overlap different methods that can reaffirm or verify the information that you find in another method. So we'll get into the specifics of that in a bit, but just think of it as kind of a Venn diagram. If one method has a weakness, you can kind of plug that in by overlapping with another method, right? So for a basic example, we talked about this in relation to surveys, right? So we talked about how one of the limitations of surveys is that they don't give you the open-ended range of responses. So sometimes people get around that with triangulation by taking a small subset of the people who responded to that survey and giving them a longer interview to ask them what they thought the questions meant to make sure that they're measuring what they think they're measuring, right? So that's one example. So what's important to know about this too is that dissimilar methods are not likely to share the same weaknesses, right? So qualitative methods are not going to have the same weaknesses as quantitative methods, right? Or vaguely, right? But even within those branches, different methods have different weaknesses. So that's the idea of kind of combining them together. So each method has a different vantage point on how it, analyzes or approaches the data. So, each has their own bias, their own potential limitations or issues with maybe, validity or reliability, right? So if you combine different approaches, this makes the researchers more confident about, like if you have two different methods measuring the same thing, like let's say you do interviews and you do a survey and they both find the same thing, that's going to obviously produce more confidence that the results that you found were accurate, right? So the strengths of one method can offset the weaknesses of another, and that's kind of the whole point of combining them together. So it also increases confidence when different methods produce the same results, kind of like what I just said. I'm not sure why I didn't click that before. Anywho, so also more than validating the findings, triangulation can be used to complement other information, such as, maybe supporting some of the arguments or claims or the justification for the research. So if you were using quantitative information to complement qualitative research, like let's say you were looking at, I don't know, I always use the homeless as an example. I'm not sure why. But anyway, if you were looking at, maybe a kind of qualitative study of homeless populations, it could still help you to use quantitative data on, the numbers of people that are homeless, the amount of people that face housing insecurity or food insecurity, something like that, to kind of back up or further justify the information that you're providing within your qualitative research study. So sometimes it's about the specific methodology and backing up weaknesses, and other times it's about providing, kind of substantive information that also complements what you're doing in that other research method. So there are multiple measures of the same concept in some of these ways. So there's two different ways to do this. So first, you can reduce the complexity of the information by making an index, which we'll talk about in a minute. So you can determine if the composite measures are related in the way the researcher thinks that they are. Because remember, we all make a hypothesis. We all kind of develop these, different ways to try to measure what we think we're measuring. But that's something that we still have to contend with. And certain methods, are a little bit more valid or reliable than others. So kind of, using the strengths of some, again, help balance the weaknesses of others. So, and the second part is if you make a model that represents the relationship among the concepts that you have, and if you measure those concepts, then you can kind of test that model to see if it fits the data. So that's what we'll call, construct validation. We'll talk about in a minute. Yay, indexes and scales. I know this is such a favorite part for students. So multiple measures are often combined into an index or a scale. So it's difficult to measure a single concept, right? with a single indicator or question. So meaning sometimes you need multiple questions to measure one particular concept, right? So not only do single indicators not capture the meaning of a concept well, they might have bias. So if you combine different indicators, this tends to balance the information and yield more reliable measure. So both indexes and scales combine multiple indicators to create a single score, right? So, you have the table example here that we'll get to in a moment. This is a unidimensional scale, so we'll talk about that in a minute. Anyway, so what the hell is an index? What the hell is a scale, right? What's the difference? So indexes combine indicators by adding or averaging without regard for how each item represents the underlying concept that's being measured, while scales combine indicators to make sure that there's unidimensionality or some other quality of the concept being measured. So there may be different things being measured, but they're all combined in the scale. So the difference between an index and a scale is a bit fuzzy, right? It's a little bit confusing. So some people conducting research use the terms interchangeably, but there is a difference, right? Like I said, an index is an arbitrary combination of indicators where you add it all together and, the responses to the questions, you're just kind of adding them without it being specific. And then you contribute to that measurement of the concepts. So the scales themselves assign scores to the patterns of responses. So constructing a scale assumes that the concepts can be understood in terms of an underlying continuum that ranges from positive to negative. So it's pretty much the same. No, I'm just kidding. Obviously, there are differences there, right? So, Gutman scaling. Let's see, did I put that on the slide? I did. Great. All right. Well, so this is, they talk about this in the text, that a person's or unit score on the scale represents the unit's response pattern on all scale items. So the book example is if you're trying to measure reading comprehension, then you would order the passages of reading in terms of difficulty, maybe by grade level, and people would be considered as pass or fail if they work their way through the readings. Then they'll measure their reading, putting it in order. There's being 1, flunking everything. 2, passing at 3rd grade level. 3, passing at all but college level. 4, passing all the reading tests. So making one of these Gutman scales is no joke. It can be really complicated, especially because you're starting with a bunch of things that you thought you were using to measure a concept, but then you have to test the subsets like you would do with the codes in order to see if they fit expectations of the Gutman scale. So the figure here are response patterns of a perfect Gutman scale, right? Like they couldn't just show you a normal, no, I'm just kidding. They're all perfect, right? So this figure here shows a Gutman scale that's working well. And that just means that the responses are patterned yes and no, and the totals for each person's total responses. So you can obtain a scale for that one person's responses, right? Because it's a pretty binary yes or no situation here. So you see here they have, a woman's own health is seriously endangered by pregnancy. So you kind of just measure you total up the yes and no's, and that gives you a, score at the bottom. And since in that context of a scale, you're thinking of it ranging, then you can kind of, you see the range from 6 to 0 here in people's scores, that's going to represent a different, context or opinion on, pregnancy, basically, because all of these are related to pregnancy or having children. So another example, or at least one I've had to use before, I think I already talked to you about it in class, is the feminist attitude scale, right? That ranges from thinking that feminism is BS to various subsets of the ideology. So people assume, you're feminist, that's it. But there's so many different kinds of feminists, right? And all of them focus on different issues. So the feminist attitude scale is just another example of this, where they're looking at, being a liberal feminist, which, oftentimes nowadays we'd call second wave or white feminism. There's also, radical feminists, multicultural feminists, Marxist feminists, right? So again, the questions that they ask in relation to those things have to do with measuring those particular frequencies. So meaning you could be a multicultural feminist that thinks it's important to look at intersectionality and, race and class and all these other things. But you can also be a Marxist feminist in that same scale, where you think that social class has a huge impact on women's power and representation in the culture, right? So it's interesting. Depending on how you answer questions, you're put in a scale of responses. And then that scale, because it's been so painstakingly created, you can take that and actually have a reflection of someone's ideology based on what they score on that scale, like numerically, right? So this is why it's so important, in that kind of context, to create a scale that actually measures what it seems to be measuring. Because if you're trying to say, okay, this person, when it comes to approval of abortion here on this table 11.3, that obviously a score of 6 is very approving of abortion versus a score of 0 right there with no matter what, even if it was rape, even if it was, the woman's health is endangered, whatever it might be. So you can see that kind of represents a different worldview. Or you could even say someone that has a 3 in response there has more of a neutral understanding or value system ideology, right? So this is just the kind of way that we take social science stuff of like, what do people think about a thing? Like, do people support, doing something about climate change or something like that? And you actually construct a scale so that you can measure and determine based on people's responses where they fall in a continuum of responses. All right, if that wasn't fun enough, now we're going to structural equation modeling. So this is a statistical technique that identifies possible relationships among a set of concepts and their indicators. So it's analyzing multiple measures simultaneously. So the equation part is how the relationship is represented with a mathematical equation, right? So this structural equation model provides information about the contribution of each indicator. So it sounds confusing because it is kind of, right? So there is an example in the chapter that tries to illustrate how it works from a study about, self-esteem and mother love, right? Using 6 indicators, realizing that the measurement is reactive. So that just means measuring one indicator can influence other indicators. So like in 11.2 here at the top of the slide, the relationship between these indicators are shown visually. So you see how, some of them are actually influencing each other, which, that's important to understand with structural equation modeling, is to see what kind of contribution each indicator is making to the overall relationship. So you can simultaneously test models and assess the quality of measurement using this approach, right? So a researcher can specify how each indicator is related to the concepts it measures. And an advantage of doing this is that it can protect from certain types of measurement error, which we'll talk about in chapter 12. So as far as disadvantages, it can be really complicated, obviously, especially to consider all possible combinations of relationships, especially if you have a ton of indicators and concepts. So it can be confusing, but again, setting these things out is so essential on paper and really trying to understand what these relationships can be, because remember, the whole point of science is to be able to be replicable. So how can someone reproduce your research if these things haven't been specified or really thought out in detail, right? So it's important to kind of set up how these things work. But again, the indicators, it's going to basically, using structural equation modeling, you're going to be able to kind of set up exactly what kind of relationships are happening with your indicators, right? All right. Replication science. All right. Science is all about getting findings that can be replicated in other studies. So that's, a big part of why, or how we can even be sure that findings are relevant and not just some fluke or due to bias or error or, a specific study or maybe the researcher themselves, right? So if something is a fact, then if you do the research, and so do I, we find out the same results. So when it comes to social science research, most of it's not focused simply on replication, unless you're talking about experimental research methods. But replications are inherently dissimilar, meaning It's not the same researcher. It's not the same population. Oftentimes, there are going to be differences when it comes to those things. Like, let's say you were doing a research study at Cal State Fullerton, and someone decided to see what replicability there was to those findings and decided to do a study at Cal State Long Beach, right? There might be something inherently different about the student populations at two different Cal States. It might be the timing of it, right? Doing something like that before a global pandemic or after a global pandemic, for example. Something of that nature that the replication itself, just because it's a different time, it's a different research, it might be dissimilar, right? And also, replications are conducted most often in experiments, like I mentioned before, because that's the principal means of enhancing external validity, right? And each study changes one or more elements of the research design. So again, remember, going back to experimental methods a million years ago, that experimental methods are kind of pure because they're trying to measure the basic relationship between specific variables in a lab setting where they can kind of control those relationships, right? But again, each study changes one or more elements of the research design, meaning you're going to have different participants. That can change what results you have, right? You might have a different time measure of the manipulation of the independent variable or a different approach. So of course that can change what you find as well. And really how you measure the dependent variable. Some of these things change as well. So it just makes sense that if the criteria is changing slightly in the research when you're trying to replicate it or, do another study that looks at a similar thing, then you're not going to find the exact same things, right? So replication is something we talk about with science, important to see whether or not something is valid. But again, let's say, some of these methods don't lend well to replication, right? So for example, I think I talked about my future husband. Oh God, I got to stop calling him that. A professor at University of Chicago, which if you Google it, you'll know who I mean. But anyway, so he did this research study, which I thought was great. Actually, he wrote a book about it now, which I have not read. So it shows how much I love him. But anyway, and basically he did this interesting study where he went down to Skid Row and did 3 years in Skid Row in order to develop these understandings of the kind of, ethnographic relationship between people and the police and each other down in those neighborhoods, right, in Skid Row. So if you wanted to replicate that, how would you do that? Would you go sit on Skid Row for 3 years? What if you're not at the same spot? What if there's different participants that you're interacting with, right? Or even just a different block, a different corner, a different part of, the city would make a difference. So a replication are inherently dissimilar. Obviously, you want to make sure we can't just be like, we can't test at the end. Obviously, you still want to have some sort of replication to make sure that these things are valid or reliable. But at the same time, obviously, when you're doing it even the same way, it's going to be slightly different because it's not the same person. It's not the same context and it's not the same everything, right? We know that society continues to change. So, even if you did a research study in 2015 and 2020, those 5-year differences might have an impact on what you find, right? So obviously, that's why, it is important, especially in experiments, like I said, because there's issues with external validity if you don't have replicability. Because again, remember, why is it weak in experimental methods in that realm? Because it's not being done in the real world, right? It's controlling for different variables. So you want to see whether or not that would actually happen, in other studies to make sure that that's something that's actually a phenomenon, right? So we'll talk too about how replications using different research strategies is a little bit different in what its goals are as well. So there are many possible combinations of research strategies, and each method we've talked about throughout the class have advantages and disadvantages. So if you want to know what people's opinions or feelings are, right, then surveys could be good, but surveys are not great at measuring what people do, right, like just what they say. But if you combined experiments with surveys, then you could compare what people say with what people do, which will make your results much more valid, right? Because we've talked about this. There's that kind of implicit bias that we all have where we're like, no, I'm great, I'm perfect, I would never do that. And then you put the person in that scenario situation, you find out what they would actually do. That's what I think is fascinating about the whole Milgram experiment. Obviously, very unethical for a lot of reasons. But what Milgram really thought was, you don't ask someone a hypothetical, hey, what would you do if someone asked you to shock someone to death? You put them in the hypothetical, right? And you look at what they actually do, right? Because again, that's going to be a weakness, a part of surveys, which we've talked about. Surveys are so prolific, they're so used very widely, but they do have that weakness among a couple other weaknesses, right? That people can just say what they think they would do. That's not necessarily what they would actually do. Right? So surveys could also be combined with qualitative research as another way to use another research strategy to try to provide a little bit more clarification as to what's going on, right? So field research and in-depth interviews can also add depth to or clarify some of the survey results. So these are just a couple examples of the ways that mixed methods can be a helpful way to validate your research findings, or at least to limit the weaknesses of a single methodology that can sometimes be, too limiting. Or again, it's not necessarily wrong. Obviously, most research studies use one method, right? The idea, though, is that if you are trying your hardest to make sure that you have the most internal and external validity, you have consistent reliability, then it makes sense to think about trying to, kind of plug up some of the weaknesses with some of the strengths of, different methods. And again, surveys, this happens often. And we talked about this even at like a pretest level, where they'll give it out the survey at a pretest level, ask a couple people, randomly of that group, of that, sample, hey, when you were asked question 5 about, your belief in abortion access, what did you think about, or what did you think the question was asking or measuring, or things like that? Because remember, we can do our best and we can put way, way too much time and thought into constructing these perfect scales and indexes, these measures to try to somehow put people's opinions and understandings on a continuum. But in reality, if they read the question and that's not their interpretation, then it doesn't matter how much thought you've put into that scale, because it's no longer representing the actual respondent, right? So sometimes I guess it's counterintuitive. The easiest thing is to be like, hey, what did you think this meant? Right? As a way to do that. But again, field research could be another way. Right? Like, let's say you were doing a survey on, campus at Cal State Fullerton, which you can't now, but, if you could, then if you were doing a survey about, let's say littering or, using the recycling bins appropriately or something like that, then you could give out a survey and ask people, what are their trash habits? Do they, take care to put the stuff in the recycling that's supposed to be recycled, or do they throw stuff on the ground, blah, blah, blah. You might have a lot of people saying like, oh, I always sort it correctly and I never throw anything on the ground. But then you could just kind of set up as a field site, a location, maybe the quad or something like that, and just actually see how do people interact with those things, or set up outside the TSU and see, do they leave all their crap on the table? Do they take it to the trash, right? Like, what do they do? Because then you can counterbalance what they're saying they're doing. And sometimes, again, if you find that it's pretty similar, right, then that just shows the validity of what you've been measuring, that what people are saying is what they're actually doing as well. But we can't just assume those things, right? We have to take the extra work and time to do these things more rigorously so we can make sure that our findings are actually what we think they are. Alrighty, so some comparisons of approaches here, right? We got this table 11.4. And so this was really just looking at strengths and weaknesses of approaches on 7 study dimensions, right? So we've talked about all of these different approaches already, whether it's lab experiments, surveys, field research, existing data, all that kind of stuff. So really it looks at how, in some of these methods, you have, different strengths and weaknesses, right? So content restrictions, what is and is not feasible or practical to study, right? Well, it is a weakness, obviously, in lab experiments and existing data, because again, lab experiments are testing things outside of the real world. Existing data isn't going to necessarily have your research question baked into it because you're using something that's already just sitting there, right? Versus if you look at lab experiments, they have very strong internal validity, right? Why? Because they can control the variables of the research in a way that you can't really do in other methods. That's why you see field research on that column is very weak, right? Because it is just what it is. You're out there in the field, you have no control over it, right? So this comparison of approaches table really shows which methods have strengths, which have weaknesses, and which are the kind of in the middle, right? Or that M of the spectrum. So you can see which kind of methods are appropriate to do in mixed methods research, or really which ones limit each other's weaknesses, right? So you can see in the same graph here that you have, strengths of internal validity with, lab experiments that you don't have in field research, right? So those things could balance each other out. So you can see with existing data, there's strengths in non-reactive measurement, control for investigator bias, external validity. Makes sense, right? Because you're using information that's already sitting there, that someone has already looked at. So it's not like you're going to have the Hawthorne effect when you're the one you're not actually conducting the research. You're just using what's already there, right? Versus, in lab experiments or in surveys or things like that. So it's interesting how, we can see that certain methods kind of fit together to balance each other out. So it makes sense that if you have weakness on one of these, instead of, the kind of medium strength, if you have a weakness in, you see with lab experiments, there's some weaknesses there. You see with existing data, there's some weaknesses there, right? Obviously, field research is kind of in the middle. There's some weaknesses. There's some, middle ground, not a lot of strengths, I guess. But anyway, really just kind of shows you how, when you're looking at the important dimensions of a research study, you can try to determine which things could actually boost the strength in your weaknesses, or again, overlap them so it limits the weaknesses in your research study, which is a very important approach because obviously you want to make sure that what you find is actually valid.